Figure 1 represents a closed electric circuit of capacitors C1 0.6 microfarad, C2 0.3 microfarad, and C3 0.9 microfarad, and a charge of 10 coulombs. Use it to answer the question that follows. So we have this circuit and we are told to determine the voltage in the circuit. So we have three capacitors, we have a voltage supply, and we have to determine the voltage in the circuit, which is the voltage supply in the whole circuit. So the first thing that you have to know is the formula for calculating the voltage, and the formula that relates charge, voltage, and capacitance is Q is given by CV, and from here we can make V the subject of the formula, and V will be equals to Q over C. Q over C. So in this case now, after knowing the formula, you have to list the variables that have been given. So V, this is what you are getting. Q is 10 coulombs. And the capacitance, we don't know the total capacitance because it is the one to use. So the total capacitance we don't know, but we can calculate it because we have the values of our capacitances of our capacitors in the circuit. Then before you get the total capacitance, or what we call the equivalent capacitance, it is good to know the connection that they have been connected, how they have been connected, the connection that has been used. And this is a series connection, because series connection connects devices end to end, not like the parallel which connects across. Then another thing you have to know is that a series connection of capacitors behaves like parallel connection of resistors. And how will this help you? It will help you in the formula of getting total capacitance if you don't remember. So in parallel resistors, to get the total resistance, we normally take 1 over the individual resistances, and later we take the reciprocal of what we get in order to get R. So in this case, in series capacitors, we shall use the same formula, whereby it will be 1 over C will be given by 1 over C1 plus 1 over C2 plus 1 over C3. And later we take the reciprocal. So this will be 1 over 0.6 plus 1 over 0.3 plus 1 over 0.9. So when you add this in fraction form, it will be 55 over 9. 55 over 9. And because we need C, not 1 over C, we take reciprocal of both sides. And when you take reciprocal of both sides, you will get C being given by 9 over 55. And when you divide 9 over 55, our C will be 0.1636. That is in 4 decimal places. And this is microfarads. So after now we have gotten the capacitance, which is the total capacitance, we can apply the formula V is equals to Q over C in order to get our voltage. So our voltage will be our Q, which is 10 over, you have to work with the SI unit. SI unit of capacitance is farads. So 0.1636 times 10 power 6, which is now for microfarad. Remember, we have also power negative 12, which is picofarad. So when you feed this in the calculator, you have to feed like 10 divide by, you put in brackets 1 point, that is 0.1636 times 10 power negative 6. And when you compute this, you'll get 6.112 times 10 power 7, and this will be in volts. So when you work with SI unit, the equivalent answer becomes or you'll get an answer which is in SI unit. So in this case, we get this, which is in volts. So that is how we could have worked out that question.